Well, welcome everybody. It's nice to see a lot of agency people here, staff people here, landowners, all kind of gathered together in the same room. And so, as a lifelong resident growing up in Blue Earth County, working with Blue Earth County Soil and Water, and kind of going to give an overview of a little bit of a local perspective, a little bit of what Blue Earth County Soil and Water is doing, and as well as Blue Earth County Environmental Services, our partners. So kind of give an overview of that, and then my coworker Ryan Jones will get into the technical aspect and side of things. So we're going to start diving down now into some of the project work and a little bit of what we have going on. So with that, you know, the typical picture of a ravine, a lot of things going on. And when we started out, I just want to throw a few pictures of ravines up there to look at. But when I started looking at this picture, I kind of thought maybe there's a few important things to point out on ravines. Not all ravines are the same, first of all. We have lots of different ravines in Blue Earth County, which we'll get to. A lot of them have different issues, but I just noticed, look at this picture that, let's see this laser pointer. There. So people put a bunch of tree debris and some tile debris and just different things down there to try to stabilize the erosion on this ravine. I didn't even really notice it when I first put the picture on, but then when I was looking through my slides, a lot of times that ends up doing more harm than good. Because when we put debris into these channels that are eroding, but we do not stabilize or properly armor or protect the actual area, what happens is the water will still come down the ravine system. It'll hit this tree debris and force it to go around it. It'll force it to go under it. If it's not properly tied in and stabilized to the correct stretch, it tends to end up doing more harm than good because they end up widening the channel or creating a diversion, which will create more future erosion. So with ravines, we just urge landowners and stuff to not just throw tree debris and rock, tile down there all, just randomly. If you're going to put a lot of rock and stuff down there, it can be good, but it needs to be keyed in properly and the right amount so that we don't end up doing more harm than good, which we sometimes see. The first ravine I showed was more of tile water outletting and going down the ravine channel, surface water flowing over the top. This ravine here is another one where neither is the case. We do not have surface water flow coming from the top down. We do not have a tile outlet, or there's tile outletting. What we have is we have some seeping, which is occurring. You kind of see a little bit of it here. There's some of it over here. And so the seeping, the lateral water is moving, the soils are unstable, and it's eroding pretty quickly, as you can see in the picture here. And so the first ravine and the second ravine need to be treated in two completely separate ways. And that's why whenever you talk about ravines today, it's tough to give, this is the answer for your problem without ever going out on site and really looking at what is going on, because every site's just a little bit different. So what are we doing in Blue Earth County to figure out what the problem is? Blue Earth County Environmental Services, Blue Earth County Soil and Water, we both work in the county, we partner together, and we're studying right now the situation of ravines. In 2005, the county was nice enough to get LiDAR, and what they did is they flew it over the county and it gives us elevation data. And so in 2005, we have a set of elevation data. In 2012, the state did a statewide flyover. So now we have 2005, we have 2012. So with Scott Salisbury, Julie Conrad, myself, and a few other technical members, we're going through and looking at what has changed from 2005 to 2012. And anything that had over 1.5 meter of change, which is about 5 feet, a little less, got red dot on this map. So far we have 240 dots on the map for prioritization. If you can see the yellow area we marked, that's where we've done the assessment. The other area that's not has not been assessed yet. So obviously we're not done. The 2012 LiDAR data, we started working on it last year, so we have not completed yet. But trust me, we know where the eroding ravines are, and we're working on trying to help pinpoint them locally, other than the ones where landowners come in. We do get a lot of landowners come in and talk to us But as far as cost share and future prioritizations, trying to determine which ravines do we start with. I mean, so right here we have 240. Which one do we start with first? So we're in the process of assessing those. Once we get the whole county done, we will go back, look at closeness to water sources, look at ones that are eroding at a higher rate. So this is a project that's still in process and by no means completed yet, but just letting people know that we are working with it, and landowner feedback is always important as we go through, and site verification, which we've done with a few people that are actually in the room today. So as we go through and look at stuff, you know, a tool we have is aerial imagery. We always look at that a lot. They fly it over all the time. The resolution's getting a lot higher quality. So we can see the site a lot more without ever having to drive out there and know that we're going to a ravine site. However, if you look at this photo, you can kind of tell where ravines are maybe, and there's a lot of trees in the way. So aerial imagery is good, but it really doesn't tell us where the ravines are and what's eroding, other than gives us a location. So from there, our GIS guy, Scott Salisbury, has helped us work with a lot of different tools and kind of puts together these cool maps for us. But essentially this is using the hillshade, which is using the LiDAR, and it's removed all the cover off of the site. So we can see straight down. So if you go, this is the same spot, I'm not changing the location for the next couple slides. So this is what it looks like from the aerial imagery with all the cover. This is what it looks like with the cover gone. So you can see the road that goes through, you can see the road bed that's raised up, the Blue Earth River channel is cut down, and you can see where the ravines go. So now we can accurately go from guessing where they start and stop to knowing exactly where they start and stop and getting a picture of what they look like. But looking at this, I don't know about you, but I really can't tell which ones are eroding. I know where they are. I can see where they start and stop, but I can't tell, are these all eroding at the same rate? Are there different rates? Where do we go from here? Another tool we use is a topographic position index, and this is kind of the same as the LiDAR. However, it just uses a little bit of color shading to help show us where the slopes are, the sides, the channel widths. We can get a little bit better picture. It's just another tool in the toolbox. As you can see, the roads show up, the fields. It takes off the vegetation, so you can kind of see right down to the source. The river shows up as a flat, solid red off to the side here. And that's just because it's at the time it was flowing, that was flat and stable. So the red color is more stable. The other colors are a little more erosion. So which ravines are more actively eroding in this scenario? We're kind of back to the same thing. When we compare the 2005 LiDAR with the 2012, we can pinpoint down that on this system, the ravines that are circled here are the ones that have the 1.5 or more meters of erosion. The other ones in the system did not. So we can start to then analyze which ravines in the county do we have that are eroding, so we can kind of get a bigger picture for legislators of how big is this problem. Everybody talks about sediment, everybody talks about erosion, how much is it going to cost to fix, how many sites are eroding. So this is what we're working on. Aside from all the people that have called our office, we've gone out and done site visits, we're working on trying to compile these in the office as well. So these are the spots we marked that are eroding. If we click back and look at the LiDAR, you can then tell what they look like with the hillshade, and from the LiDAR pictures. As you can see, this one looks really bad. However, it's not really eroding anymore. It's somewhat stable. So visually with the hillshade, not all these systems can be eroding. Some of these are. Some of these are right next to the river. Some of them are a ways back. So what we can then do here is basically look at, if soil erodes here, how long is it going to take to get directly into a system as opposed to soil eroding here? Like I said, we're still putting together the tools of how we're going to prioritize which ones are we going to address first. And just right here on the system alone, there's a handful of sites, and this is only one small picture of the whole county. So when people always ask, do you have money to stabilize ravines? The answer is yes, and the answer is no. Because we do have it for some, we don't have it for all, because we do not have the funding sources available, and we'll kind of get into the cost as we move on. So funding sources, once we identify these problems, people go, landowners here in the room today, how can we get assistance to stabilize these projects? Well, myself and Ryan Jones will be at the case study tables this afternoon, and so we will be there to help answer more detailed, specific questions for each landowner. We can go over more technical things, so I don't want to pigeon anything down to one site, but in the afternoon we can get more technical as we stand over there. But you can either go to Blue Earth County Soil and Water Conservation District in our office, located out on Victory Drive next to John Deere, or the Natural Resource Conservation Service, our federal partners. We have a state cost share program, offers 75% cost share assistance. Landowner pays 25%. NRCS has the EQIP program, the Environmental Quality Incentive Program. It's a flat rate program, but the flat rates were established targeting trying to get to 75% cost share assistance. So as people want to address these are the two programs that can kind of help get that done. One other thing that now Blue Earth County Soil and Water has access to that our federal partners do not is grant funding sources. We have the Clean Water Fund with the Board of Water and Soil Resources. We've received many different grants since that's been around. Clean Water Fund has been good. 319 Clean Water Partnership from NPCA. We have funding sources there. There's a lot of other funding sources too, depending upon, but mainly for ravines, the Clean Water Fund and the Clean Water Partnership has been where most of the project dollars have come from. But in order for us to apply for these grant funds, we need to know where the sites are. Because when we apply to these legislators and we apply to people that are trying to get money here locally for your projects, they want to know the name of the person, the location, the sediment reduction. Has to be prioritized, has to be a measurable result, has to be a targeted effort. If we just say we want money to fix ravines because it's a problem, they say so does everybody else. What are you going to do? We need to know exactly what we're going to do when we pitch these sales, and so we have to have site assessments or landowners that come to our office. We have a lot of landowners that walk in the door and want to do projects, and that's great, we appreciate that. We don't always have funding to help them, so sometimes people don't come in and say, oh, we know there's no funding today, but we really do need to know about your project so that we can put it down and we can submit it in an application on a yearly basis, which we do, to get funding to get out to the land. Because that's really the important part of what we're here for today, is to get projects on the land. So with that, we've identified the eroding ravines. We maybe have some funding, we maybe not, depending upon how good the grant stuff goes. So now what? Now we're really to the troubling question of ravines and how do we fix them, and that's where I'll turn it over to my counterpart, where I'll come in with the technical expertise. I'll also come back up for questions too at the end here.
Does that work? Okay. Forward and back. Point. All right. So yeah, we've identified, I'm Ryan Jones. I'm the engineer for the South Central Technical Service Area. It's an area that covers 11 county SWCDs based around kind of the Mankato area. And it's funded by the SWCDs and with a grant from the Board of Water and Soil Resources. We get sites, and the member SWCDs give me a call and have me come out to do a site assessment to see what can be done. And I guess my purpose today was to just walk through the kind of the steps involved in assessing a site and coming up with the potential design and all the way through construction. So it's really geared for the landowners. Again, we'll also be here this afternoon for specific questions. So this is a little kind of explaining the process, and we can get into specifics on a kind of individual basis. So when I get a call to come out to a site, first thing that we do is we find the site and get together some information that we can from elevation contours, calculate, for instance here we've got the watershed, try to determine how much water is coming towards the ravine, surface flow, if there's public buried tile that are draining towards it, that's something we can look into too. We also look at the soil type in the watershed, gives us a little information as to how much water is coming, how fast towards the ravine. Also the soils and the slope The slope of the ravine itself, how quickly it's falling, gives us an idea of what practices might work and might not work. And then the overall change in elevation, how far from the top of the ravine to the base where it meets the river or the floodplain. It gets to issues related to what could possibly be done. How is this access going to be a concern for construction? We come out to your site and take a look, and this project here, there was a couple of large, I think there's 8 and a 15-inch tile at the top of the ravine, causing a lot of the problem. You can see the debris, stumps, and things that were dumped in an effort to try to stabilize. We look for outlets, seepage in the ravine. If there's a point in the ravine where it becomes more stable, so we're kind of looking to see where maybe the project endpoint would be, where we could outlet water into the ravine and have a reasonable chance that the erosion is going to be less critical from that point on. We look at the farming practices, and we want to design something that works with what you're doing out there on the land. So that's part of what we're taking pictures of and looking to get ideas of what could be done. Talk with the landowner about tree removal. Is that going to be a potential issue? Are there some specimen trees that you want to try to work around, or some landowners you can just take whatever you need, and so we need to know that. And access for construction. If we try to build something, can we get back there with equipment? Is there access during the summer, or is it something that has to be constructed during the early part of the spring or in the fall after the crops have been taken out? So I guess it says here, most importantly, what are the landowner's goals and expectations? These are voluntary programs, and we're trying to come up with something that works for each individual case. After the site visit, gives us an idea of what types of designs to do, and we go back to the office and come up with a preliminary design. And there's a kind of a laundry list of practices that could be used on the low impact end of the spectrum. You have vegetation, vegetated buffers, maybe some reinforced vegetation, different types of mats that can be used to help reinforce the soil. It gets a little more involved. There's places where you can install upstream storage to try to slow the flow of water. You get into rock checks, drop structures, which there'll be some pictures of, lining with riprap, rock, and then piping. So those are, it's different for each site conditions. So something, again, work with the landowner, and it's debate comes down to funding, how much money is available and how much the landowner wants to pay, and just the topography, what'll work and what won't. This was a design where it called for an embankment and just real rough, enough to get some quantities and a basic cost. So it's my chicken scratchings, and I think this was estimated at, as shown with the drop structure, embankment, piping, $25,000. This one actually was put in for a grant and that didn't get funded, so it's sitting on the shelf. Hopefully at some point the money will come available and the landowner will still be interested, and we can get something installed. If Jerad or whoever the district manager is, if they work out the funding with the landowner and get everything on board, we go and do a site survey, and this is just showing kind of the elevation contours that show up. So when we come and do a survey, we're looking for the lay of the land, upstream of the ravine, there's areas where something might be constructed, or we're trying to figure out where water goes exactly. If there's any structures in the area that might be in danger, tile inlets and outlets, culvert storage are important. Utilities, edge of field, so we can either try to know how much of the field we might be encroaching on. It's always a concern for the landowner. As far as just a practical matter, especially for these working ravines, there's kind of a limited time frame where it's the easiest to do these surveys. It's in the spring before the leaves come out, and in the fall after leaves drop. And after the crops are harvested, we can get physically back to some. These sites are always located away from the road, behind the 80-acre cornfield. So we try to work around it, get access when we can. We work. This is just an example. We come up with a plan. All the information that's needed to build the practice. We also come up with the construction specifications, and this is, if you ever can't sleep at night, you could take a look at this, and this might do the trick. It's very technical, but at the same time, you need this to make sure that things are done right, that the compaction is done right. This is a spec on excavation, and it just outlines everything that the contractor is supposed to do. So if there's a problem, the specs say that you're supposed to do this. Just making sure that the project is done right, and that details like this are important. We prepare an estimate at the end of the design, and once things are ready, what we think it's going to cost. We get information ready for the landowner. The landowner, at least in the programs we work with, the landowner is responsible for selecting contractors and obtaining bids. The SWCDs have lists of contractors in their county that you can go out and contact, and we give bid forms so the contractor doesn't know what the estimated price was and try to get best cost. Ideally, the things come in right in at what the engineer's estimate is, or below. Sometimes it comes in higher, and then we got to look at it and see, is that just the contractors aren't really excited about doing the work, or is there what's causing the price to be off? Is there something we can change, or try again next construction season when things might be less busy for the contractor? We also, I work with the technician. Between the two of us, we're out at the sites doing the inspection. We do the staking, so the contractor knows where to build embankments, say, or put in various structures. We take care of that. We do the inspection to make sure that things are being installed correctly. This is showing a drop structure with hooking into tile lines, and this connection needs to be grouted, sealed with concrete. So you can see either me or someone there on the site taking pictures. Looks hard to find. Looking back, getting ready for this, it's hard to find pictures where we're not somehow taking the shadows into account. So going forward, we'll try not to be pictured. So I was asked to put some just project examples together, and this is one project where we constructed a small berm with a drop structure and a pipe. And this is just a kind of a portion of the plan. I'm not going to go through things in too much detail here, just to kind of show the detail that is in the construction plans. Profile, so you're showing the drop structure and the culvert with riprap protection on the downstream. So this gives you a little bit of storage on the upstream, and then it conveys the flow to down further into the ravine where things might be a little more stable. You also get some controlling the rate in which the water goes down factored into the design. So this is we do the staking. This is the showing the kind of the center line of the embankment. There's another flag here, another one on the other side of the ravine somewhere. And this, obviously this tree is going to be removed as part of the project. The drop structure, the inlet, outlet pipe, and then this smaller one is for drain tile to come in and tie into. So we're collecting the drain tile and also bringing that into the system. So it's we're kind of trying to eliminate some of those all those discharge points along the edge of the ravine. The outlet with the rock for energy dissipation at the outlet, and the ravine is a little more stable going downstream from there. This shows the berm we constructed, emergency overflow. So when if some large storm, the pipe inlet gets overwhelmed, the water is conveyed through a grass channel here and down into the ravine. I'm going through these kind of quickly, but just to give you an idea of the practices that are involved. This project here was $22,000 for the earthwork, the structures, and some tile work, rerouting the tile. Yep. It wasn't particularly large. I think they had to bring clay in from off-site, so that was part of the cost. The length of the pipe was 74 feet of culvert. So,
not the width of the pole, but along the top ridge.
The top of the berm?
Yeah, how long is that?
I don't know offhand. Another project example, this is a little more involved, but it kind of shows some of the other options that are available as far as projects. This involved some drainage from a roadway and from a housing development, as well as flow from a field. It was coming overland and flow from the ravines themselves. There are some structures that were at risk here and here also. So this was in Decoria Township in Blue Earth County. The solution to the drainage involved collecting the tile. This is the one earlier that showed the 8 and 15-inch drains, collecting them in a metal structure, and then piping the flow down the ravine with a HDPE, kind of a rigid pipe. This was the before condition. This is during construction. They've started hauling in clay to raise the elevation of the ravine in order for construction access and to widen the channel for installing some protection. This is the HDPE pipe going down the ravine alignment. It's a 12-inch pipe. It's 50-foot sections that are fused together. Yes?
Could you give me, like a $22,000 project, could you just say how many clock hours would you spend doing engineering on that project?
As design, might between survey is probably a day's worth. The drafting and the design and the drafting depends on that, but 40 to 80 hours altogether, and then
2 weeks for $22,000.
and that's a lot of it is drafting up the plans and the specs. And they say typically the engineering can run anywhere, depending on the project, 15% of the cost. Fluctuates on the size of the dollar amount. Smaller projects, you take more time as a percent of the construction cost. So it's the ballpark is in there. The design also called for putting a riprap channel down the alignment of the ravine. This is kind of the finished condition. The riprap is for the surface flow. Would come. The pipe was for the subsurface flow. And then this was after 1 year. So it's started to get, the vegetation has taken hold, and I think we're also helped in that because of the tree removal. There's a little more light was able to come into the core of it. So with that, this was $147,000. So this isn't your typical project, but elements from this could be applied to smaller scale projects. This was driven by some roadway issues and the residential issues, so that drives the funding. And I'm going to take questions. This one, I'd say there was a 60 to 80 foot drop. Not uncommon in Blue Earth County. Yes?
What was that, 100 yards long, or 75 yards long, or 200 yards long?
It was probably 400 feet.
400 feet?
Through the pipe, it was designed according to the standard. I think it was more than a 10-year flow. There's a lot of inlets in the ditches that have the control risers on them, so there's some storage, but it was a issue with just a continuous flow causing the saturation in the ravine as well.